Hello, I'm Supreetha. Welcome to my math class. So in the previous lectures on hypergeometric series, we studied about the introduction. We gave an introduction for hypergeometric series. Yes, we studied the definition. Yes, we studied about the definition of hypergeometric series. We studied about the convergence on hypergeometric series. And then in the previous video, we studied about the proof of hypergeometric equation, the ODE. Yes. So in this lecture, let us study about the binomial theorem. Yes. What is this binomial theorem? What does it state? Okay. So the binomial theorem states that for mod z less than 1. Yes. Mod z less than 1. What does this mean? It means that the series converges, right? We have summation n is equal to 0 to infinity an. What is an? The Pochammer symbol. N factorial z power n is equal to what? 1 minus z to the power minus a. Okay, where an is equal to, what is an equal to? A into a plus 1, so on up to a plus n minus 1, right? So let us start the proof. We start the proof by taking, okay, let us take the series, that is summation n is equal to 0 to infinity an divided by n factorial into z power n. Let us denote this with fa of z. Okay. So now let us find fa dash of z. So what do you mean by this? You're just differentiating the equation. What would you get? N is equal to 1 to infinity an divided by n factorial into n z to the power n minus 1. Yes. So what do you do next? So you have n in the numerator and n factorial in the denominator. Yes. What can you replace it with? N divided by, can I write n into n minus 1 factorial? Yes. So n and n gets cancelled. Let me replace it now. I would get summation n is equal to 1 to infinity. So a at n divided by n minus 1 factorial into z power n minus 1. So you can observe that we have n minus 1 over here and n minus 1 over here. Can we do something to get n minus 1 over here too? What is the Pochammer symbol? Pochammer symbol is an is equal to a into a plus 1, so on up to a plus n minus 1. Yes. Now let me just reduce this. Let me just take this element out. Yes. So then I can write a. So the first element is a plus 1. Yes. And I've decreased n by 1. So I'll write n minus 1. Okay. So let me write it as n is equal to 1 to infinity a into a plus 1 n minus 1. Yes. Divided by n minus 1 factorial into z power n minus 1. Now I have all the three as n minus 1. Let me replace n with n plus 1 basically to get n, right? So I would get n is equal to 0 to infinity. Okay, let me mention that I am replacing n with n plus 1. Okay. So what would I get over here? I would get a into a plus 1 n divided by n factorial into z power n. Yes. Now this is nothing but, what was this? Fa dash of z is equal to f a plus 1 of z into a. How did I get this? You see, I wrote fa of z is equal to summation n is equal to 0 to infinity an, right? In the place of a, I have a plus 1 over here. So in this place of a, I have written a plus 1. So this a was a constant, it was extra. I can take it out of the summation because it doesn't have n with it, right? So I just took it out of the summation and I got this equation. Let me name this equation as equation 1. Yes. Okay. Now let us find fa of z. Okay. fa of z minus fa plus 1 of z. What is fa of z? The series n is equal to 0 to infinity an divided by n factorial into z power n. What would a plus 1 be? As I told you, just replace a with a plus 1. Yes, I would get a plus 1 at n divided by n factorial into z power n. So let me take out 1. Okay, I'll just take out one element so that I would get 1 plus. Yes, I would get 1 plus 1 term from the summation. So this would be n is equal to 1 to infinity. Yes, I would get a n divided by n factorial z power n minus 1 again. Okay, so I would get plus here, right? Okay, so let me keep it as it is. Summation n is equal to 1 to infinity a plus 1 n divided by n factorial z to the power n. Okay. So if I take this negative sign inside, if I multiply it, 1 and 1 gets cancelled. Agree? So I can write in the next step, summation n is equal to 1 to infinity. What all do I have common? Let me take out some common terms. So I would get an minus a plus 1 n divided by n factorial, yes, into z power n. Okay. So let me just simplify this term. What is an? An is a Pochammer symbol, I know. How can you write an as? An can be written as a, yes, a into a plus 1, so on up to a plus n minus 1. Right. What can a plus 1 at n be written as? We can write that as a plus 1 n terms, okay? A plus 2, so on up to a plus n. Yes. So you see, you have a over here, right? So if you take so many terms, so yes, you have these terms here and here from a plus 1 to a plus n minus 1. You would get a plus n minus 1, the term before a plus n. So let me write that down. Okay. So this would be a plus n minus 1. Okay. A plus n minus 1 into a plus n. So now I can write this term as a into a plus 1 at n minus 1. Yes, I've taken out a. Yes, from this I can take out a plus n. Okay, so that is a plus n into a plus 1 at n minus 1. Agree? Let me write this over here in that equation. Okay, this is equal to the summation n is equal to 1 to infinity. So I'll replace a n with a into a plus 1 n minus 1 minus I'll replace a plus 1 n with a plus n into a plus 1 n minus 1. Yes, let me write z power n divided by n factorial over here. Again, can you see that a plus 1 n minus 1 is common over here? Let me take that out. Okay, is equal to 1 to infinity. So I would get a minus n, where a and a gets cancelled. I would get a plus 1 n minus 1 z power n divided by n factorial. Yes, again you get n divided by n factorial. Can I replace it with this? Can I replace it with 1 divided by n minus 1 factorial? Yes. So that would be summation n is equal to 1 to infinity. I'll take out minus sign outside the summation, and then I would get a plus 1 n minus 1 divided by n minus 1 factorial into z power n. Now again, let me replace n with n plus 1. Okay, I'm replacing n with n plus 1. Yes, so this is equal to minus summation n is equal to 0 to infinity a plus 1 n divided by n factorial z power n plus 1. Agree? Now, can I write this z power n plus 1 as z power n into z? Yes. So I'll take out z because z is free from n, right? I've taken it out of the summation. So this would be a plus 1 n divided by n factorial into z power n. Again, I can write this as, yes, I can write this as f a plus 1 of z, right? So what was there on the LHS? What did we take? F of, okay, f a of z minus f a plus 1 of z. Okay, let me write that down. F a of z minus f a plus 1 of z. So this is equation 2. Okay, now let us divide equation 1 and equation 2. Yes, this is equation 1. This is equation 2. Let us divide them. Yes, I've not written minus z over here, right? What if I simplify this? I would get fa of z is equal to, let me send this fa of z to the RHS. I would get 1 minus z, right? fa plus 1 of z. Okay. Now, I'll name this equation as equation 2 and let's divide it. Okay. So, yes. Dividing equation 1 and equation 2. Okay, what is equation 1? Fa dash of z. Fa dash of z is equal to, yeah, a fa plus 1 of z. A fa plus 1 of z. Okay, divided by fa of z. Okay, so this is 1 minus z into fa of z. And here I would get fa of z. Now, here obviously, okay, this was fa plus 1 of z, right? So I would get there fa plus 1 of z. So clearly fa plus 1 of z gets cancelled. Yes. So let us integrate this. What is the integration of fa dash of z divided by fa of z? Integrating, what would we get? So on integration, we would get, isn't this log, right? Log fa of z. Yes, log fa of z. And then we have a as a constant. Did we miss a negative sign? No, is it? Okay. Okay, yes, we'd get it over here, right? So what is integration of 1 divided by 1 minus z? Yes, integration of 1 divided by 1 minus z. What would that be? I would get log of 1 minus z, and then I'd have to integrate this again, so I would get minus, right? So I can write over here minus log of 1 minus z. So let me write the constant as log a. Okay, so can I write this as log of 1 minus z to the power minus a? Yes, plus log a. Again, can I write this as log a into 1 minus z to the power minus a? Yes. So we have log on both the sides. Correct? So now I can write this as fa of z is equal to a into 1 minus z to the power minus a. Agree? Now, can you observe that we have almost arrived? Yes, we have almost arrived at the binomial theorem statement. There's only one thing to be proven here. What is that? We have to prove that a is equal to 1. Yes, to prove that a is equal to 1, first let me put z is equal to 0 in the above equation. Okay, what would I get in this equation? Yes, let me name this equation as equation 3. Okay, putting z is equal to 0 in equation 3. Okay, so fa of 0, what is fa of 0? 1 to the power anything is 1 itself. So I would get fa of 0 is equal to a, right? Now, take the first equation, that is fa of z, this one. Okay, let me name this as anything like a. Okay, so let me write from a, yes, from a, what do we have? Fa of z is equal to summation an divided by n factorial into z power n. Yes, from this. Okay, let me split it. Okay, that would be, yes, that would be a 1 divided by 1 factorial into z. Okay, we have 0, right? So if you put 0, the first term of the summation would be 1. Okay, 1 plus this plus a 2 divided by 2 factorial into z square. Now what would you get for fa of 0? Okay, fa of 0 would be 1. Agree? Because see, if I put 0 over here, this would become, the whole thing would be 0. So the whole series or the whole summation terms would have z for sure, because it is z power n. This is the only term which does not contain z. So that is the only term we would get for fa of 0. So what is fa of 0? Fa of 0 is a, right? So we can write, or we can conclude that a is equal to 1. So did we arrive at the binomial theorem's statement? So let me just write it down. We're there. Yeah, fa of z is equal to 1 minus z to the power minus a. Yes, what was fa of z? Summation n is equal to 0 to infinity an divided by n factorial z power n, which is equal to 1 minus z to the power minus a. Yes. So how did we prove this? So firstly, the statement of binomial theorem was for mod z less than 1, which means that the series is converging. Yes, we have the summation. Okay, an divided by n factorial z power n is equal to 1 minus z to the power minus a, where an is the Pochammer symbol. So we started the proof by taking fa of z is equal to the series, that is summation an divided by n factorial into z power n. We differentiated it and we came to the equation 1. Again, we found fa of z minus fa plus 1 of z, and we arrived at equation 2. And on dividing 1 and 2, we got, but after integration, we arrived at an equation which contained an integration constant. Yes. And then by proving that the integration constant a is equal to 1, we arrived at the binomial theorem. Okay. That's it for today's class. Thank you.